Hi everyone. Today we are going to learn an extension from the chemical formula that you have learned. We call it the empirical formula. But before that, let's look at this diagram. This is a diagram of ethene molecule. Here's a formula of C2H4. Just a very simple question. What is the simplest ratio of the molecular formula? If we simplify 2 and 4, we get CH2. How about the next one? Sodium chloride. We all know the simplest ratio of sodium chloride is NaCl. The next one, silicon 4 oxide. It is SiO2 because one silicon there's 2 oxygen atoms. If we simplify the ratio, this brings us to a new term we call empirical formula. The name empirical formula refers to the formula that is derived from scientific method. It's not by theory, it's through experiments. And we define empirical formula as a formula of a compound which shows the simplest ratio of atoms present, whereas molecular formula is a formula that shows the actual number of atoms of each element present in a molecule of the compound. For example, again, looking at the same example, ethene C2H4, the molecular formula is C2H4, but the empirical formula is CH2, which is the simplest ratio. And we can have a general formula to tell us that empirical formula can be simplified by this value of n, or we can say that molecular formula is a multiple of the empirical formula. Now let's look at an experiment on how we determine the empirical formula of a substance. In this diagram, we have a crucible with magnesium ribbon, and we are going to heat the crucible. We all know that when we heat magnesium ribbon with oxygen, we will produce magnesium oxide. As the start of this experiment, we measure the mass of the empty crucible with lead, and then we measure the mass of crucible together with magnesium. And lastly, we measure the mass of crucible with the magnesium oxide after the experiment. From these three masses, we can actually determine the mass of magnesium as well as the mass of oxygen. To find the mass of magnesium, we minus B with A. And to find the mass of oxygen, we minus C with B. For this experiment, there are some precautions that has to be taken in order for us to get good results. First, the lid must be lifted occasionally to allow air to enter. This is to ensure that the combustion has enough air. Second, the solid must not be allowed to escape as white smoke, because if white smoke is escaped, it will reduce the mass reading. Third, after a while, lid may be taken off and open the crucible to heat strongly. This is to ensure that the combustion reaction is complete. And lastly, cool before weighing. And the process of heating, cooling, and weighing must be repeated in order to get a constant mass. Let's look at an example on how we do the calculation to get the empirical formula. First, we need a table to help us. In this example, it says 2.4 gram of magnesium reacts with 1.6 gram of oxygen. And we have the mass here. To find the mole from mass, we divide by molar mass as we have learned. And so magnesium is divided by 24 and oxygen is divided by 16. And we find the ratio of the moles by dividing by 0.1. At the end, we get the ratio is 1 to 1. The simplest ratio is 1 to 1, and hence we can conclude the empirical formula of magnesium oxide is MgO. For the second example, we have an unknown compound, X, and it tells us it has 27.27% of carbon and 72.73% of oxygen. And first, we need to assume 100 grams of compound X for easy calculation, and therefore we will have this mass for carbon and oxygen, and the rest of the steps are similar. First, divide by molar mass to get the mole, and from here, to find the ratio, we divide by the smallest number between the two, which is 2.273. And now you get the ratio of carbon to oxygen is 1 to 2. And we can conclude that this compound is actually carbon dioxide. For the third example, it's talking about a hydrocarbon compound. The meaning of hydrocarbon, it means that this compound contains hydrogen and carbon only. So it has 85.72% of carbon and the remaining is hydrogen. There are two parts to this question. The first part is to find the empirical formula. The second part is to find the molecular formula, which is the actual number of atoms present in the compound. And the relative molecular mass is given. First, we find the empirical formula using the same steps. First, we assume of 100 grams of hydrocarbon. We use the table. From the mass, we find the number of mole by dividing by molar mass. And we divide by the lower number, which is 7.14, to get the simplest ratio. And lastly, we can say the simplest ratio is 1 to 2. And we can conclude the empirical formula is CH2. For the next part, we want to find the molecular formula. We know that the molecular formula is the empirical formula multiplied by n, whereby n is a constant. We know the empirical formula is CH2, but we do not know what is the molecular formula. But what we know is the relative molecular mass is 42. So by using this, we can form a simple equation whereby the mass of CH2 is 14, and we can solve the simple equation. You'll get n is 3, and therefore we can conclude the molecular formula is C3H6. And that's all for today's lesson on empirical formula and molecular formula.